Alright, and welcome to graphing vertex form of a quadratic. So the first thing that we need to know to start this video is what is vertex form of a quadratic? Well, it can be written like this. F of x is equal to a parentheses x minus h squared plus k. Okay, and whenever you go to graph these things, the way that the graph is going to change from the parent function is going to depend on these values of a, h, and k. So first let's start out with what is the parent function. Every single function has what's called a parent function, and a parent function is just the simplest form of that. So for quadratic functions, a parent function is f of x equals x squared. Anytime you see this square and that to the power of 2 is the highest degree, what you're dealing with is a quadratic function. We can just abbreviate function. Okay, so that's the parent function, and the parent function looks something like this. It has a vertex at the origin, 0, 0, and it has a positive a value, and it opens up this way. Okay? Now, from here, anytime you do anything to x squared, like for example, let's look at our example we're about to work with. Here we have subtracted 4 from the x value, and we've subtracted 9 from the entire function. That is going to change the graph somehow, some way. So let me give you a quick rundown of how these letters change the outcome of our graph. Okay, whenever we see this a value, if it is a positive a, we'll say that our graph opens up. And if it's a negative a value, you would say that the graph opens down. Okay? Also, the a value determines how wide or narrow the graph is. So when a is greater than 1, it gets narrower, and what we're going to do is we're going to call that a vertical stretch. And as a is less than 1, then we can call that a vertical compression. Okay? Now from here it actually gets pretty easy. This minus h value, whatever you do to the x value, simply moves the graph left or right. We'll use a fancy word, translate. It translates it left or right. And the k value will move our graph up or down. Okay, so with those things in mind, I would encourage you to pause the video and write those things out, because you're going to use this formula or formulas similar to it for the rest of the year. But with that out of the way, let's tackle this problem. Okay, when graphing f of x equals x minus 4 squared minus 9, there's only one itty bitty piece of math that I have to do. I go inside the function where I see x minus 4, and I want to set that equal to 0. So no matter what function it is, anytime it's in vertex form, you go inside the function, so that means inside the part where we're squaring it, and you always set it equal to 0. And then you solve for x. The opposite of minus 4 is, of course, plus 4. So let's add 4 to both sides, and x is equal to 4. Now this tells us some pretty interesting things. Firstly, we can identify the vertex. It's at 4, comma, and then you just look at this k value, which is really the y value of your vertex, and so we'll just write negative 9. No math required. Now what is that telling us? This is telling us that we're going to be translating, I want you all to write that word at least one time, translating, and since it's a positive 4 in the x position, it's going to translate right 4 units, comma. And this negative 9, since that's in the y position, we're going to be going down 9 units. Okay, so let's do this next graph in blue. And this is where we can graph it and see visually what's going on. We know that our vertex is going to shift to the right 4 units. So let's just do this, where that's the value of positive 4. And it goes down 9, so we'll write negative 9. And this is our vertex. Now notice the a value is a positive 1. That's the number in front of the parentheses. We don't see a number, so we assume it to be 1, and it's positive. So since it's a positive 1, it's actually going to have kind of the same width as our original function. It's not going to get wider or narrow. It's going to be basically the same. And now the last thing that we want to do is we want to go ahead and just label some key pieces. Okay, firstly, let's label our axis of symmetry. I like to have students say, okay, what letter do you see in the word axis? And you're always going to see the letter x, implying whatever the x value of our vertex, the axis of symmetry is going to be that, x equals 4. And the axis of symmetry goes through the vertex and it cuts the graph in half. This would be the axis of symmetry for our parent function. Okay, so there's our axis of symmetry, that dashed line that splits the graph in half. Down here at the bottom we have our vertex, but since it's a vertex and it's at the bottom, we can actually call that our minimum. And lastly, the last thing we just want to note is that where this graph crosses the x-axis, we can call those our x-intercepts or our solutions. Now we don't know where they're graphing here, that's why we call it a rough sketch. But yeah, those are the key features that you need to label. The vertex as a maximum or minimum, where is the axis of symmetry, cutting the graph in half, and the solutions. Alright y'all, I'm going to do 2 more examples, and these are from the assignment. So whenever you think you've got this, you can go try it, and then if you get stuck, you can come back to the video. But I would encourage you to watch example 2 and example 3 if you're really stuck or not understanding this. Okay, here we have example number 2, and it says describe the transformation of the quadratic function below from the parent function and label the key features. Now once again, the only math you have to do is you have to look inside the function where we see this x plus 6, and we're going to set that equal to 0, and then we solve for x. So what is the opposite of plus 6? Well, that would be minus 6. And so x is equal to negative 6. Now this actually allows us to know where the vertex is, negative 6 comma negative 8. And how would you describe that? Well, when your x value is negative 6, it means that you are translating or shifting left 6 units because it's negative, comma, and this negative 8 is telling us, hey, we are going to go down 8 units. Okay? So we've gone to the left 6 and down 8 units. And then the next thing we notice is that we have an a value that is not 1. Our a value is 2. Now how does 2 compare to 1? We know that a is greater than, or we know 2 is greater than 1. When your a value is greater than 1, what you have is a vertical stretch. A vertical stretch. What that means is that your graph has gotten narrower. So let's see what this looks like in practice. Our vertex is at negative 6, comma negative 8. So you go to the left 6, down 8. And since we said this graph is narrower, we're going to kind of draw this skinnier than we would our parent function. Alright, now the next thing we want to label is, let's label our axis of symmetry. We know that this goes through the x value of the vertex, so we can say x is equal to negative 6. That is our axis of symmetry. Over here, let's say, you know what, our vertex, it's still at the bottom, so we know that this represents a minimum. And then the last thing we want to label is the 2 places where this quadratic function crosses the x-axis. And those are going to be my solutions. And we can also call them x-intercepts or zeros. There's a 4th word, roots, but let's just keep solutions, zeros, and x-intercepts. Alright, let's move on to example number 3. Okay, for example number 3, I'm actually going to do problem 4 from the assignment. And the reason I chose that is because this is the first time that we see a negative a value and also a fraction. Okay, but let's go and start out with the inside of our function. We see this x plus 4, and we know that whatever is inside the function, we're going to set equal to 0. Now, how do I get x by itself? Well, what is the opposite of plus 4? That's going to be minus 4. So let's subtract 4 from both sides, and 0 minus 4 is negative 4. Okay, so I know my vertex is negative 4, comma, wait a second, positive 3. How is that going to change this? Well, we're going to go to the left 4, so there's negative 4. And this time we're going to go up 3, and there's my vertex. Now I also noticed that my a value is equal to negative 1 over 3. So in this place, you're going to kind of divorce this negative from the number itself. And this is really the only time that I'm kind of aware that this happens in math. When we have that negative value, that's going to tell us something very specific. I'm going to write it over here. Whenever you see that negative, it's telling us that our graph is being reflected across the x-axis. And what that means is that our graph is now going to open down. Okay, so I'm just going to write this kind of in shorthand over here. It opens down. The next thing is this 1/3. We look at the 1/3 separate from the negative, and I know that when a is equal to 1/3, that tells me that a is actually less than 1. So that means we have a vertical compression, which is another way of saying that the graph gets wider. So I can actually go to this graph right now, and I can draw it just very, very wide and indicate, yeah, we have some sort of vertical compression or some sort of flattening going on. Lastly, we can tell from our vertex, from the -4, that we translated left 4, and this is a +3, up 3. And you can kind of see that clearly from the graph. Alright, I hope this helps, and I'll catch you in our next video.